Hello and welcome back to Polytoots. In today's tutorial we're going to be making a VFX shader with both Shadergraph and Amplify shader editor, and what you're seeing here is mostly based on a GDC talk by Blizzard's lead technical artist Julian Love. This is back in 2013, I don't know what he's up to nowadays. But it's where he talks about the VFX of Diablo 3 and the people in the comments get angry because it's not the original Diablo. It's a blast. See the link in the description if you want to check it out for yourself. There seems to be a bit of confusion about two things that Julian mentioned in his talk. The first is this mysterious blend add shader he talks about, something that could be both alpha blended and additive at the same time, something that all tech artists secretly know, but you can't find any information anywhere on the internet. The other confusion is where he says,
and we randomized the offset of their UVs for every texture and randomized their scroll speeds.
And we'll be covering that too. So just before we get started, I should clarify that we will be kicking off this tutorial with both Shadergraph and Amplify, but then I will be carrying on with just the Amplify version, and you'll find out why, so I'm not just being mean for the sake of it. You can hop on over to my Patreon for a free download of both shaders, but I will also go over the Shadergraph version at the end of the tutorial to talk a bit more about how certain parts were converted over. I am also using the universal render pipeline, but you should be able to remake this in HDRP or the legacy rendering pipeline if you're still using that. Okay, so in true Polytoots fashion of annoying everyone who's watching, we're not going to jump into the shaders just yet. Instead, I'm going to cover a bit about default blending modes like what you're seeing on screen now. And even if you already know this stuff, it's worth sticking around for the minute or two it'll take, because there is some weirdo, funky stuff going on that is worth pointing out before we make our own shaders. What you're seeing here are default Unity particle shaders, as in just standard Unity materials with the blend mode changed on each one. So we've got alpha blended over on the left here, and then additive, multiply, and pre-multiply. They're all running on the same particle system with the exact same settings. Ignoring the weird flickering that's going on, you might be thinking that the alpha blended example on the far left and the pre-multiplied example on the far right look pretty much the same, and I would forgive you for thinking this because I'm pretty sure Unity's pre-multiplied material isn't correct. We'll talk more about this later, but Unity have another pre-multiplied shader that you can find buried in their legacy stuff, which I'd have thought wouldn't work on the new render pipeline, but it does, and this actually looks correct at first glance. I know I haven't told you what correct is supposed to look like, so for now, all I'll say is the brightness down at the bottom and the darkness as it goes up is what we're after here. That is, what you would expect from a pre-multiplied blending mode. We'll talk more about this later, but I just need to get through this bit before my subscriber count starts taking a hit. This legacy shader has a minor flaw though, in that if your texture itself isn't pre-multiplied before you even assign it to a material, meaning if your actual texture file that you've saved out of Photoshop isn't already being exported with the alpha on top and set to multiply over the texture underneath, then the shader isn't going to work. And I'll just quickly prove this by sticking on a pretty normal texture that is not pre-multiplied by its own alpha. For the most part, this is actually okay, especially if you're just looking for a flexible VFX shader on textures that you're already pre-multiplying in Photoshop or whatever else you use. In fact, I would argue that this is probably even a better option than making your own shader with Shadergraph, which might sound weird, but you will find out why now, because we're finally going to get started on some shader stuff. So that's the intro done. To begin with, I'm just going to create our blank shaders. So we'll start off with the Amplify version, and we'll go with the unlit template because we have no need for PBR lighting here. We'll give this one a name, and then we'll do the same for the Shadergraph file, again going with the unlit template. And for those of you paying attention to the file names here, you might have already caught on to the secret of this legendary blend add shader. In fact, you might have guessed it before when we were talking about the blend modes, but I'm thinking that most of you probably skipped that. But either way, there is no secret, there's no dark magic afoot here. Blend add is just a pre-multiplied blend mode. And that's the reason you can't find any tech artists or anyone talking about it on the internet, because everyone just calls it pre-multiplied. I'm going to split screen these shaders for now while we work on them in tandem with Amplify on top and Shadergraph underneath, just like how it is in reality. And we'll start super basic for now and just create a texture asset in each shader, making sure to hook the RGB into color and the A into alpha. We're also going to go ahead and change both of these shaders over to pre-multiply. With Shadergraph, you do this via the little cog icon on the master output. Just make the surface mode transparent and the blend mode set to pre-multiply. Then save that out and we'll do the same thing for the Amplify version. Now let's create ourselves two materials from these shaders, one Amplify and one Shadergraph. If you just right click and create a material while having a shader selected, it will automatically create the material using the shader you've selected. I feel like I could have used a lot less words to explain that. Oh well. I already have two particle systems in the scene here. They are the same as before, I've just renamed them for clarity's sake. So we'll stick our relevant materials on these and we'll get our Diablo 3 inspired particle texture on them. And let the confusion begin. This is pretty weird, right? There's actually two strange things happening here, but let's just address the most obviously wrong one, and this is actually the Amplify version. If we take a look at the materials, you can see that the Shadergraph version looks correct. It at least has alpha happening. The Amplify version, however, does not. I'm not sure why this is the case, but in Amplify you need to do two things. The first is to tell the shader to use a pre-multiplied blending mode, and the second is to actually pre-multiply the texture yourself. But you don't have to do it in Photoshop, but it's pretty much the same thing. You know, like in Photoshop we grabbed the alpha and multiplied it with our RGB, so it's the same thing. We're just going to grab the RGB and multiply it with the alpha before sticking it into our color slot. So it's like we're pre-multiplying it ourselves, even though we've already told Amplify to do it. I don't know, it's weird, but either way, we'll save this out and ta-da! Now it looks like things are correct. Looks like it, at least. The keen-eyed among you may have noticed that we're not getting any of the colors or alpha from the particle system. And this is just because particle systems handle this with Vertex data, so we need to get that into the shader in order for these two things to communicate with each other, while remaining socially distant, of course. It is 2020 after all. So we'll start off by just multiplying our texture with a color node. This isn't part of the Vertex stuff, by the way. It's mostly just so we can enable a HDR range for some of that sweet, sweet bloom. Plus, it's just nice to have additional color controls. Now we'll get our Vertex color node, and we'll throw in another multiply because we want to multiply the RGBA of this node with our current color setup. And then we'll also multiply just the alpha of this node with our textures alpha. This is what lets the particle system interact with our shader because we're driving our stuff through vertex colors and alpha. Oh, and here's where I finally remember to enable the HDR checkbox on that color node. So now of course we'll do the same for the Shadergraph version, which is almost identical to how we just did it. The only difference is we need to use a split node to get the alpha component of the vertex color node. But that doesn't happen in the video yet, so we've got some time to kill. There we go. There's that world-class editing that you're all so familiar with. So let's have a look at both of these. Remember that the Amplify version is on the left and the Shadergraph version is on the right. Something is quite obviously different here. We're getting a nice glowy color on the bottom of the Amplify version and there's no such thing on the Shadergraph. Bear in mind that even though our colors are set to HDR ranges, we're not using a HDR value on either shader yet. From what I understand, when you use pre-multiplied blending, it means that you're getting alpha blending at full opacity and additive blending at 0 opacity. This is why Julian calls it the blend add shader. It's both alpha blended and additive at the same time, and it's the alpha that actually controls this. So if we come to the particle system here and start playing around with the alpha, you can see we're able to force it into an additive mode, which is pretty awesome. But then you might be thinking, hey, wait a minute, if full opaque is alpha blended and full transparency is additive, then how do you actually fade your particle out to nothingness? And how do you actually have 0 visibility on your particle? Well, that's also controlled with color, you see, because if a texture is additive but black, then it will be invisible, since black additive just isn't a thing. If we come over to the Shadergraph version real quick, even if you start tinkering with the HDR ranges to try and get something that matches, the results are just not the same because of course cranking up the HDR value is going to lighten all values consistently, which is not ideal for a super hot fire bellowing out dark chunks of smoke. So this is where we say goodbye to Shadergraph for now. We'll catch up with it again toward the end of the tutorial, but for now let's just carry on with Amplify, and in all honesty there's not much left. We just need to introduce some noise into the alpha, and then make it appear randomly and scroll at random speeds, and then, that's pretty much it. I've gone ahead and made a duplicate of the Amplify version to continue working with. I'm just mentioning this now because the shader that we just made is actually quite a good VFX shader by itself. So I wanted to keep it separate for the download on Patreon, which is free, by the way. I don't know if I've mentioned that before, like a million times. So let's get started on some noise to mix in with our alpha. And yes, the scene has fog in it now. I'm just dropping one of my random noise textures in here to get it started. This is also included in the download, by the way. Everything is. I'm going to multiply this noise with our alpha for now. I usually use the R channel for noise textures since it's just a black and white information, but for this setup it's actually important to use the alpha channel. I don't understand the math behind it, it just looks better this way. So if you don't have an alpha channel in your noise textures, just use the Unity conversion to create one from grayscale. That should be fine. I want to come back to the particle system for a moment and wipe some of the settings, so what we're seeing is the same particle appearing one after the other without any randomization getting in the way. Since we're sticking with the Diablo 3 style, our texture actually has the shadows painted in, meaning we can't be rotating these particles around like crazy because that would just look all sorts of weird. We can allow some rotation of course, but we'll get to that later. For now, I just want something super basic so we can easily see the changes that our shader will have on these particles. So back to the shader then. I'm gonna just pan this noise texture in the way that you might expect, and then we can see why that just isn't going to work. If you see here, the repetition in our mask is quite easy to spot, and this is the bit that we need to randomize per particle. So to do this, we need to come down here to the renderer section and enable the custom vertex streams. This is where the video gets even more boring, unfortunately, but basically the end result here is we want the particle system to control certain UV operations within our shader, specifically the panning of our noise map. That way we can actually randomize these operations per particle spawned. And if you see here in the custom vertex streams, there is a UV entry already in the list, and it's saying UV text chord 0 XY. This is actually just the default texture coordinate range. XY is just another way of saying UV. To make this a little bit more confusing though, text chord 0 is actually text chord 1 in Amplify Shader Editor. It's a little odd, I know, but look, here's a texture coordinate node, and you can see a list of the UV sets. It starts at 1, so technically that is what Unity refers to as 0. You might also notice that this is set to a float 2 by default, so U and V to be precise, which is going to be the X and Y on that custom vertex stream we just mentioned. So this information is already in use by default, you know, it is our U and V. If I change this to a float 4, suddenly we have two more options, W and T. This will be known as Z and W on the custom vertex stream, which I know sounds stupid when I say it out loud, and even when I say it in my head it's a little weird. Without going into details, they're basically the same thing, but UVW is more about 2D space, whereas XYZ is all about the 3D. It's weird, I know, and in an ideal world I think we should have just used XYZW for everything, but you know, it is what it is. So with that non-explanation out of the way, we need to come down here and add our own vertex stream. We'll use the custom1.xy, which you'd think wouldn't make sense since I literally just told you that the XY information is already in use. And that's still true, but XY in this context is actually just saying two channels, X and Y. And what it will tell us when we put it in is that X and Y is already being taken by text chord 0, so instead it gives us the ZW to use, which is available in text chord 0. If this is the first time you're learning about this, I understand how strange it seems, but hopefully I'll remember to leave a few links in the description that might help you out. So now we can come up here to custom data and enable custom 1. This being called custom 1 and us adding in the custom1.xy vertex stream is not a coincidence, by the way. So we'll set the mode to vector, and since we've already specified that we want to be working with two channels, we can set it to a vector 2, which of course defaults to X and Y, but in this context it actually relates to Z and W, because if you remember when we added the custom1.xy, Unity let us know that XY was already taken, so our custom 1 data will be for ZW, which is just two channels. Right, back to the shader for one hopeful last push then. I'm going to put down some register nodes here, one for our main textures alpha and another for our noises alpha. This is, it's not available, I think, in Shadergraph, this kind of functionality, but it allows you to basically register any bunch of nodes that you have, and then you can just use a get node to basically teleport that feature somewhere else, so you don't have all of these lines and spaghetti going all over the place. But either way, I'll be doing this sort of thing a lot in a minute because I do like nice tidy graphs. So let's use some of those get nodes to take our texture alpha and multiply it by our noise alpha. And then if I'm following the Diablo 3 recipe correctly, we need to multiply these by 2. And I'll throw in a saturate here as well, just to make sure the values aren't getting blown out. Then I'll just make another register for this called alpha, and I'll come back to our base setup here and use another get to add that into where we're multiplying the alpha of our vertex color. I'm also going to throw in a bit of a curveball here and get the same alpha again, but this time multiply it by 4 and then multiply it into our color setup. And here I'm just registering the color setup itself, so I can move it out of the way and then forget about it, just like all of my life's problems. Just remember to get the base color register and feed it back into the multiply here. Now we're ready to sort out all of that noise mask stuff, and again, following the Diablo 3 recipe, the idea is to not only have random offset and scrolling per particle, but to also mix in our noise 3 times. One with half tiling, one with normal tiling, and another with 2 times tiling. So that's what all of this setup you're seeing here is all about, starting with the UV node, and then we'll put down a panner here for later. I'm using a component mask node to split the UVWT into just 2 channels, and I'm registering that as UV times 1, since the default UV output here is times 1 tiling. Then I'm going to register the T slot as time and the W slot as W because I couldn't think of a good enough word. I'm then going to multiply W with a vector 2 that I'm calling direction, because the values we specify here will determine the initial scrolling direction of our noise. And I'm just registering this whole thing as a node called direction. So if we come back over to our panner here, we can start hooking some of these things up. First up is the UVs, which go into the UV slot, the direction node, which goes into the speed slot, and then the time node, which goes into time. This should all make sense in a minute once we save all of this and come back to our custom data tab on the particle system. So the first vector 2 value here, we can turn into a random between 2 constants. And what this will do is any numbers we put in here will multiply the numbers based on our vector 2 direction setup in the shader. This isn't going to have an obvious effect without time though, and that's why I've set the second vector here to have a curve, because a static number isn't a value over time, it's a constant over time. Whereas with a curve, we can specify to start at one time and end at another in a linear fashion. Hopefully you can see the results for yourself here. We're not seeing the exact same mask pattern repeat exactly the same across every particle. We're only doing this for one noise though, so there's still going to be some repetition in there for sure. So let's go back to the shader and finish this puppy off. The first thing I'm going to do is put 2 more texture sample nodes down, and in the mode I'm going to set it to reference and then pick the reference as our noise texture. That way it will just use the original noise texture that we're using, so we don't have to plug more textures into the material. Then I'll copy and paste these panner nodes plus 2 of the get nodes, since we're going to be plugging in different UVs for these anyway. And just like what we did the first time, I'll add a component mask node set to XY and multiply it by 0.5 and register this as a different UV value. I'll do the same again, but multiply it by 2 this time, meaning one of our UVs is half as small as the original and the other will be twice as big. And then just because I felt like going a bit rogue, I decided to add these 3 noises up with static switches, so we can specify on the shader whether we want single, dual, or triple noise panning. Then I multiply this result by 2 and stick it into the register value that we'd made earlier. So this is not too shabby in my opinion, especially for a shader with just 2 textures in it. So let's get our particle system back to the way that it was and also take a look at that Shadergraph version. The first set of nodes here are what we already covered in the beginning of the tutorial. It's just the texture multiplied by a color multiplied by vertex color. And then down here, most of it is the same as before. We have our texture again on the left, and we're multiplying the alpha with the vertex color alpha. The new thing here is that we're also multiplying in this other noise texture, and here's the UV setup for that, which I think might actually be simpler than what we did on the Amplify version, but don't tell anyone I told you that. And that pretty much wraps up this tutorial. To be honest, as disappointed as I am with the Shadergraph version, it is doing things different enough in its own special way that seeing it here, I don't think it's too bad. The motions are quite fluid, and with a HDR value of 1, it's okay, to be honest. But yeah, that will be that. Be sure to let me know your thoughts in the comments, if you'd approach this in a different way or not, or any thoughts on things you might like to see in the future, or just any thought you might be having right about now, even that number that just popped into your head for some reason. It's 15. Lastly, I just want to give an absolutely gigantic thank you to all of you who are supporting the channel on Patreon. It blows my tiny mind hole, and I hope to keep giving you all the good stuff in return. In a socially distant, responsible way, of course. Thank you all for watching, and I will see you in the next one.